if you are doing data analysis and wish to count the unique values of your data frame, then the value counts function from the pandas can help you. So before we proceed, download the ebook in the description below. This ebook is special and good for because it uses a simple data set. It is interactive and has visual illustrations, and I've designed it by using pandas documentation. So this is a comprehensive step by step and practical guide for you to learn this value counts function from the pandas. So this book is unique and it will give you the aha moment right away at the starting of learning any new concept. So download it so that you can follow along in this tutorial. So assume you are having this data frame and you wish to count the unique values, the unique rows. That means you need to get an output of Debra CPU 1, 2. You need to get a unique Freddy monitor. Freddy monitor. There are 2, but also John software. It is single row. So this is just a simple data set that can help you to get a clear understanding of what this function can help you in pandas. So here we use this. This is called DF. For example, our data frame is called DF. So you can say DF dot value counts, and then this output, expect to get this output. So let's see it practically. So this is manager, and this is product, and this is the count. So this is output that we are going to, let's see it practically. So practically, let's first import pandas SPD. Let's first import pandas SPD and then create this data frame. So after creating our data frame here, we can count the unique rows from this data frame by writing data frame dot value counts this way. See? So the next step is, so data frame, this is our data frame, and that we should expect to get this way, this so value count has parameters like subset and many other parameters. Let's start with this subset. The subset parameter accepts a label or a list of labels. So it specifies the columns to consider when counting a unique combination. For example, if you want to count how many times does each product appear in the data frame regardless of the manager from this data frame here, then you need to use the subset parameter, and it has to accept a single column. The example here, the product. So our data frame, so if we create this data frame, and try to, okay, from this data frame, then we can can count the unique product regardless of the manager. Regardless of the manager. So we are having the subset equal to product. You see? So we are having the unique SPU 2 monitor SPU 1, monitor 2, but software 1 from the product column. So when the subset accepts a list of columns like product and price, then it can return counts of unique combination of those columns regardless, for example here, the manager. So if we have a list, then it can return so here it can return we are having an error. So let's create first our data frame. Create our data frame. After creating our data frame, let's now count the unique product and count the unique product and the price. You see, you can get the unique product and the price. If you can't specify the unique the subset, then it count the unique rows of data frame, like this one. So we expect to see the unique rows, the unique count. The other parameter is normalized. This normalized parameter returns proportions rather than frequencies. It accepts a Boolean value and default to false. So if you want to understand what this normalized parameter solves, you can see here in this data frame here, when the normalized parameter is false, then it will show how often each unique row appears. It's by default. But when the normalized is true, it shows the proportion or percentage of each unique row, as you can see here. 0.4, 0.4, 0.2. So let's create a data frame and try to see practically. So we are having this data frame and we wish to use the normalized parameter to see how it affects our data. So the next step here, when it is false, when it is true, it will bring the proportion or percentage of each unique row, and when it is false, let's say the normalized parameter is false, then you expect to see then the unique counts as if there is no normalized parameter. This is by default. So by summary, you can see this here in the screen. It can help you to grasp the concept of normalized parameter. You can also try to question the count and the proportion of a unique combination of manager and the product. This will help you to understand the use of normalized parameter in data analysis problems. Let's move on to the next parameter. Sort parameter, I accept a Boolean value and the default to true. So this sort parameter, it sorts by frequencies when true, and it also sorts the data frame column value when false. So this is a simple and a short way to show you the use of sort parameter when true and when false. You can see from these two explanation of the sort true and sort false. So by default, it will sort the frequencies, most frequent first, and when you set sort false, it will sort by data frame column values. For example, here you see it started by the most frequent, which is banana. Banana has appeared 3 times, but when false, it starts with the value the apple A B C or B A O. So that's how sort when false and true works. So practically, you can see this this one data frame and wish to count value counts, but you want to sort, say true. You see, sort the most frequent first. When false, it will sort by values of the column or a data frame. So this is false. You see, it starts with A, B, C, and so on. So this is how the sort parameter works. The ascending parameter accepts a Boolean value and default to false. It controls the order in which these counts are sorted. For example, here from these simple illustrations that I've designed, you can see the difference between when so ascending false and ascending true. You can see here. So when the ascending false, it sorts from largest to smallest, as you can see here. And when the ascending true, it sorts from the smallest to the largest. So practically, if we say here we are doing ascending false, you see, we start with the from largest to smallest. But when we start with true, see, start from with the smallest to the largest. This is how the ascending parameter works. So the last parameter is drop none. This drop none parameter will accept a Boolean value and default to true. It does count rows that have missing values, but the simple illustration in here can give you understanding what this sort parameter is. See from this one, when they drop not a number, the rows that contain values, missing values, are not counted. But when they drop now false, it will count even the rows that contains the missing values. So let's try to see this practically. So I create this first, say that we have not imported the numpy. So let's first import numpy as an p. You see, so we have created our data frame like this, and now we wish to count value counts. Drop now parameter is equal to true. You see, it has not counted the non-values, missing values, but when you use false, it will count even the columns, the rows containing non-values. See, the non-values are 2. So this is how the dropna parameter works. So you can download this ebook from my GitHub account by clicking the link here or the link in the description below. So thank you. See you later.